Jai Hind everyone, my name is Aman Gupta and I am working as an assistant professor in MC department in Akgec Engineering College. So my subject is software engineering and my subject code is BMC 302. My topic is requirement engineering process. In this wide topic, I am taking that requirement analysis, that how can we do the requirement analysis. So first of all, the requirement gathered during the process of requirement elicitation, that is the first part of requirement engineering. Next is the requirement analysis, and in this we analyze, refine and scrutinize all the requirements that has been gathered from in the process of requirement elicitation, and all the data that has been gathered is to be analyzed and refined to get it consistent, and unambiguous requirements needs to be removed. This is the refined version of the requirements. So there are some steps. That first, draw the context diagram that is needed. Develop prototype, it is the optional part of the part, and model the requirement and then finalize the requirement. So these are the requirement analysis steps needs to be followed in any requirement engineering process or analysis process. So first is the draw the context diagram. So it is a simple model that defines the boundaries and interface of the proposed system with the in the context of the external world, how these work. So we are taking the example of result management system. So when we talk about result management system, there is an entity that is the administrator who is going to have result management system. Subject information entry he can do, student information entry he can do, and marks entry operator can do the entry in the marks entry in the system. And what students get, information reports generated, and then mark sheet generated, what is the outcome of that part, and the student performance reports generated. So that is the one part, that the generation of reports. So that is the outcome of that result management system. Next is the development of a prototype. So prototype is a actual system that is a virtual prototype, virtual solution of the problem statement that helps the client to visualize the proposed system. That this is the prototype that I am going to have after my product or is ready. Then this is the software, or this is the look that my software have after the completion. So it increases the understanding of the requirement. When we see some prototype with all the requirement at one place, then it maybe give a clear picture to my mind that what type of outcome or what type of software I am going to have. So this prototype may help the parties to take the final decision. So this is not a mandatory part to create a prototype, but it may help the clients to view the solution of their a prototype of solution of their problem statement. Next is the model the requirement. So this process usually consists of various graphical representation of a function, data entities, external entities, and their relationship between them. So we are going to have diagrammatically in the form of some pictures or graphs, that entities that we have some, as we see the in use case, that we have some circles, use case, actors, and a relationship between them. So this type of graphical representation, through these type of graphical representation, it may be easy to see all the functionality easily. So graphical way may help to find incorrect, inconsistent, and missing requirements. So with the use of that, we can have the clear picture of all the requirements. So these models include a data flow diagram, how the data will flow, from one to another process through processes. Entity relationship diagram, that is called the ERD, DFD, data dictionary, and state transition diagrams. Next step is the finalize the requirement. So after modeling the requirement, inconsistencies and ambiguities have been identified and correcting the flow of data among various modules have been analyzed, that it has been working okay. Now finalize and analysis requirements, and the next step is to document these requirements in a prescribed format. So first model that we are talking about is a data flow diagram. So data flow diagram is the graphic or visual representation of data flow through business processes. We can have, we can see that all the requirement we can easily explain in detail that what type of process we are going to follow, and in the and this is in the graphical, through graphical representation. So these help in the visualization of the flow of data and its transformation by different processes. So these diagrams show the route that the data takes to flow within a system. They show the transformation of storage as well as the data by the processes. So we are going to have the transformation of storage, data, and how data go from one process to another, that has been shown in that data flow diagram. So the arrows represent the transfer of data between two elements which are within the system. So this is the representation or relationship we are showing through with the help of arrows. So they show the transfer of data between different entities as well as the different data storage media. So these elements are within a system. The DFD does not show the elements which control the data. So these doesn't show the elements which control the data, but it show the elements that have the data storage and the entities having some data or the process. So the DFD show the flow of data through the system. So there are some considerations that needs to be followed, that all names should be unique. It is not a flow chart. It is a process system. It suppresses logical decisions. There is no if-else conditions, defer error conditions, and handling until the end of the analysis. So this is the arrow that used to connect the process, that is the data flow, and this circle or the oval shows the process and perform some transformation of its input data to yield the output data. So these are some symbols, that source or sink, source of system inputs 0, sink to of system outputs, data store, repository of data. The arrow head indicate net input and net output to the store. So we have some certain levels of that. If we talk about the DFD data flow diagram, we have level 0, level 1, level 2. So these represent that what type of abstraction, what type of level of abstraction have been done in that type of DFD. So when we talk about level 0 DFD, it is called the fundamental system model or context model, and it represents the entire software as a single bubble with input and output data that is indicated by incoming and outgoing arrows, that I show that this is the process and this is the single, this is the level 0 representation of level 0 DFD. Now in level 1 DFD, it provides a detailed view of requirements and flow of data from one bubble to the another. It is a detailed version of the problem statement or the requirement. So this is the level 1 DFD of result management system. As we can see, we have multiple bubbles through which these are the actors, or the this is the functionality, and we are going to have that teacher, actors, administrator. And what a teacher can do, a teacher can enter username password by having this, then he can log into the system. And and what can administrator do? Administrator can see the report generation, student performance report, and student information. Data entry operator can have the can do the information, subject information can be entered by the data entry operator, and with the help of these he can have subject details, all subject details, and these details can be managed, info management, marks information management, and in this process they can have the mark details. So this is the complete overview of the problem statement or the result management system, that what are the people that are engaged in this process, what type of process they are having in that process. All the functionalities of the system have been defined in this level 1 DFD. Now next is the level 2 DFD, and in level 2 DFD we are defining the define in detail a particular situation or particular functionality of a or a module of a complete problem statement. So in this we are taking the, in level 2 we are taking the DFD of login, and in this login system a user account info and retrieve user info by having that username password. A student or a teacher or an administrator, when you enter their username and password, can log into that result management system and having their functionality in that system according to their roles. Next is the data dictionaries, and it is a file or a set of files that includes a database metadata. And metadata is the information about himself. So the data dictionary hold records about other objects in the database, such as data ownership, data relationships to other objects, and other data. So these are the informations that is contained by the data dictionary, and it includes the information about the following: data, about data, this is the rule of some metadata, and these are the following content that has includes in the data dictionary: name of the item, it can be your choice; aliases, it represent another name or the nickname of that item; description of what the actual text is all about, this is also contained; related data items with other data items; and range of values, that it will represent all possible answers. So all these details are included in that data dictionary. Next is the ERD, entity relationship diagram. So it is a detailed logical representation of data for an organization, and it uses the three main constructs. First is the entities that may be called actors in term of if we talk about use case diagram or DFD relationship, we can define it with the help of arrows and then the attributes that are going to have implemented in the problem statement. Now first is the entities, fundamental thing about which data may be maintained. So each entity has its own identity. So the entity type is the description of all the entities to which a common definition and common relationships and attributes apply. So this is the entity type. What is a relationship? Relationship is a reason for associating two entity types. So these binary relationships involve two entity types. Okay, so this is the arrow that shows the relationship between two entities. A customer is insured by a policy claim is made against a policy. So we can see relationship are represented by diamond notation in an ER diagram. So this is the relationship between these two, customer and the policy. So this is the relationship which we connect with the help of this arrow. Okay, and the customer is insured by the policy with the help of policy, which is made against the policy claim. So this is the relationships added to the ERD. So we can say that policy claim, after that policy claim, this policy claim, the relationship between policy claim and policy is the made against, because this policy claim is made against that policy. So this is the relationship between policy and the policy claim. Now the degree of relationship. So it is the number of entity types that participates in that relationship. There may be some one-to-one relationship, that is called the unary relationship, binary relationship, ternary relationship, that how much and how many entities are involved in that type of relationship. So in unary relationship, that is one-to-one, that some person is married to another person. So this is a relationship from one person to another person. So this is the one-to-one relationship. Now employee manages what, this is the employee, maybe, or maybe some, it is connected with many roles that he have been performed in some organization. So he manages this also, he manages this also. So these are all the roles. So this is the relationship are one to many. Now binary relationship, the example of binary relationship, employee is assigned parking place, that is one-to-one. That particular employee is assigned only one parking space, is the example of one-to-one relationship. Product line, some product line contains the product. So product line means that some, if we talk about some type of furniture products, so these contains all type of furnitures only, that chairs, sofas, beds. So this is called the product line of some furniture items. So this is the relationship between the one to many. Student registers for this course. So many students registers for courses, some apply for B.Tech, some apply for M.Tech. So this is a maybe one student, two student, three students. So this is the relationship many to many. Ternary relationship. So it cardinality and optionally two entity types A be connected by a relationship. So the cardinality of relationship is the number of instances of the entity B that can be associated with each instance of the entity A. So the movie is stocked as videotape. This is the example of the ternary relationship. Now we have some attributes. So each entity type has a set of attributes associated with it. Set of attributes. So attribute is a property or the characteristics of an entity that is of interest to the organization. That is called the attributes of an entity. So if we talk about student can have some attributes. It have some student ID, student have some name, he has some address, and he has some phone number. So these are all are the attributes of the student entity. So student is an entity and these all are the attributes of this entity. If we talk about ER diagram of result management system, this is the ER diagram, entity relationship diagram of result management system. So we have admin, data entry operator, and what is the relationship? It is a user. It is working as a user on the basis of some user ID. He can log into the system with the help of some password. And what data entry operator? It is maybe he is also a teacher, maybe he is a student, or he can take subject, student has result. So maybe data entry, student has some name. These are the attributes of student entity, enrollment number, date of birth, and what he can see, marks obtained, status of its result, pass or fail, with the help of that student ID, with the help of that attribute. And result shows the total marks of the student. So this is the overall year diagram of the result management system. Next is the requirement documentation. So this is the way of representing requirement in a consistent format, because documentation is very necessary, as we already see in our process requirement elicitation, in which we gathered all the information. Next we see the requirement analysis, in which we see that the gathered information has been refined and analyzed, and now that data needs to be documented. So SRS serves many purpose depending upon who is writing it. First of all, they may be it is written by the customer or it is written by the developer, and the SRS serves as we already discussed, that it acts as a contract between the users and the developer. Now, what is the need for the requirement, software requirement specification? So, the problem is that the client usually does not understand the software or the software development process. So, it is important that developer should tell the customer that this needs to be done. And sometimes happen that developer does not understand the client problem and application area. So, the problem arises in that situation, that there may be a communication gap between the parties, both the parties. Parties are what? User and the developer. So, these two people are involved in a development project, and if there is some communication gap, so the quality software may not be developed. So, a basic purpose of software requirement specification is to bridge this communication gap. So, SRS is the medium through which the client and the user needs are accurately specified to the developer. So, this provides a reference for validation of the final product. So, high quality SRS is prerequisite to high quality software. The high quality SRS means that all the requirements are gathered or written in a proper format that can be easily understood by both of the parties, and it is very important to make a high quality software. So, this high quality SRS reduces the development cost, because the requirements are not changing every time, that this needs to be done, this needs to be done. It is already freezed and documented in a document, SRS, that we called as SRS, and it should contain, correctly define all the requirements, not describe any design details, and not impose any additional constants. So, these are the points that SRS should have always included. And there are some characteristics of SRS, that it needs to be correct. So, if SRS is correct, then all the user requirements are stated in requirement document. The stated requirement should be according to the desired system. Unambiguous means the requirements unnecessarily not to be repeated. So, it is unambiguous when every stated requirement has only one interpretation. So, this implies that each requirement is uniquely interpreted and not to be repeated. Now, next is complete. So, SRS is complete when the requirements clearly define what the software is required to do. So, this includes all the requirements related to the performance, design, and the functionality. Verifiable. So, SRS is verifiable when the specified requirements can be verified with a cost-effective process to check whether the final software meets those requirements or not, or requirements are verified with the help of the reviews. ranked for importance stability. So these are not equally important. Each requirement is identified to make differences among other requirements. SRS is modifiable or not. The requirement of user can change, hence requirement document should be created in such a manner where those changes can be modified, and also it is with cop up with the structure and the style of the SRS. It maybe not change the structure of the SRS. Traceable. It is also a characteristic of SRS that when the source of each requirement is clear and it facilitates the reference of each requirement in future. Next is consistent. When the subset of individual requirement defined does not conflict with any other functionality, it means that SRS is consistent. Now, and the last is requirement validation, that check the document for completeness, consistency, conformance to standard, requirement conflicts, technical errors, ambiguous requirements are not or existing or not. So these are all the requirement validation for documentation. So this is the process, that SRS document, validation process, approved actions, organizational knowledge, organizational standards, SRS document, list of problems. So this all can be checked during the validation process. So this is the requirement review, requirement verification process. First of all, plan, review, distribute SRS documents, read all the documents, organize the review, follow up action and revise the document. So this is the process of reviewing any requirement process. So that's all for today. Thank you so much.